Let's understand a bit the concept of stationary points, inflection points, and critical points. So first, what is a stationary point? By definition, by the word itself, stationary means that the function stays. Stationary points. The function does not increase and does not decrease, meaning that the derivative, the rate of change of the function, equals to 0. So graphically it looks like that. For instance, at this specific point, we can see that the rate of change of the function is 0 because the slope, the tangent line to this graph, is flat. The function does not move, it just stays. Then it starts rising and it flattens out on the top again, where the derivative is equals to 0. And mathematically, if you think about it, delta y over delta x. Even if we increase x at this point, there is no change in y because we're still moving along the same y value. So the change in y would be 0 divided by delta x, and that's equal to 0. I hope this makes sense. So that's a stationary point. Now, what relationship does that have to do with local minimum or local maximum? Well, look, you see that if we have a stationary point and at the same time the rate of change of our function is increasing, look, we go from flat to steeper slope, steep, and so on. So we're going into a convex shape from a stationary point. We're starting from the bottom, from a local minimum. So we have a stationary point with a convex shape. That is the criteria for a local minimum point. At the same time, if we go over here, we also have first order derivative equals to 0 because it's stationary. First order derivative is equal to 0. But now look what happens to the slope here. It was steep, but now it flattens out until it's completely flat. So it's the opposite. We are flattening the slope. The change is decreasing, so the function is increasing at a decreasing rate, and that was the condition of a negative second order derivative. That would be the condition for a local maximum, a local peak on the graph. It doesn't mean that it's the highest point of the entire graph. We must check also the endpoints of the graph and so on. But locally, it's like a hill. Now, besides that, what possible value or what possible point can we have for a local minimum or a local maximum? These are called our critical points. These are called our critical points. And our critical points are of two types. Either we have a stationary point, just like in this case, with a flat slope, meaning that the rate of change is 0. And the second case is where the derivative is undefined. And how does that look like? Where f prime x is undefined. We'll have a look over here. At this very point, we can see that we're reaching a peak as well, but it's very sharp. Now, do we have a rate of change over here? We do not, because we cannot take the point of a tangent line on this on this shape. You know, it's not a curve. It's literally very steep, very angular. So we do not have a defined rate of change at this point, but still it is a local maximum. So whenever we check for local minimum or local maximum, the critical points could either be on the top of the curves, where it's either a local mean or a local max, or it could be on this angular shape where the derivative itself is undefined. Let's leave it like that for this video. In the last video, in the next one, we'll go through inflection points.